Hello everyone, I'm Xia Yoga. Okay, next we'll actually do it in these few steps. The idea is still quite clear. First, we need to read this configuration. How do we plan to read this configuration? Let me show you our current configuration. We just write it like this. But you can extend these configurations according to your own needs. There's no problem at all. Our main configuration is placed here. Here we have an any configuration for the login server. We use this section format and write it in a key value way. We didn't use GConfig because we're worried GConfig might cause some issues, so we define and parse it ourselves using the native fstream method. First, we need a singleton. This singleton is used to obtain this configuration. Yes, then we also need a structure to describe this log. We can also use JSON. UEC and is completely fine, but here we still use this thing we wrote earlier. Using JSON is perfectly acceptable because in the previous two chapters we demonstrated how to write JSON. Let's call it this. The singleton we manage. We need to have it include our type here because we plan to write our corresponding type here. It should be written here. This is the configuration used by the server, so writing it here is fine. First, include it. We haven't written it yet, but that's okay. It is a singleton, so we need to provide a method so that it can be accessed externally. Obviously, this is a get method. Once we have the get method, we definitely need to prepare a global singleton, a globally unique singleton. Then, after we have this singleton, we need to, during its construction or initialization, what's it called? Just declare it. You see, alright? Declare it as a null pointer. At this point, we create this get function. This is all very traditional C++ practice, and don't do this outside the main thread. Do this kind of thing. Because we haven't set this up, because all of this kind of stuff must be initialized in the main thread. So that's why we didn't make such a complex design. Then, at this point, we destroy it. So when we exit, we definitely need to destroy it. So, for destruction, we check if this pointer exists. If it exists, we delete it. Then we just set it to null. If it doesn't exist, we just leave it alone. These two static methods. Next, we need to write an init method. We go to initialize the local disk to read information. Okay. Good. Then, we have this method from elite. We are going to start reading this information. So, how do we read it? First, we still need to include the log. Let's paste the log. Good. After we paste this log, we will print it. At this point, we start to initialize our configuration information. When pasting here, it sometimes pastes the previous software over. Okay. So how do we go about doing this? First, we prepare a string. Because we are reading text, first prepare the string. Then we write down this path. This path is obviously, we'll have it written here. Let's change the name. This part is a bit tricky. Actually, it's just reading this locally. The IMI file on the disk, then find it. Then we read it. Then we take this file and read it onto this content in this way. But during the process of reading it, it is very likely to fail. That is to say, why does it fail? Because it might not exist. So we first write this as a failure. We write it as a failure if the content count is less than 0. That means it is a success. Success means it is greater than you. If it fails, we should prove that we are probably in the initialization process, and it does not have this file yet, so we need to log it. That means our loading failed. Loading the login server failed. Because the file does not exist yet, so we now auto-refresh it. Then if the book is not found, how do we refresh it? Actually, it's very simple. We just write it back. Then we add this. For the first line, we write this. And for the following lines, we just write this. Then add this port. Then this is a struct. We haven't written this struct yet. Let's not write the struct for now. Then we save it to disk. So we want this data to be used in the form of a struct rather than as scattered variables placed on the member. Therefore, we need to prepare a struct here. This struct, 国页, let's call it config info. We need to change the name. We don't have this struct yet. Next, we'll write this struct. Let's write it here. Write it under our server type. That is, some configuration information used by our server. So this struct actually looks like this. Let's copy the name of it is this. So what do these names mean? Actually, the first one is our common token. And this one, we use MD5 encryption. We'll just copy a blueprint here. As for this version, let's set it to 1.1. For the port, let's set it to 80,033. There's no problem with this. Okay. Once that's done, we go back to our config. There should be no issue here. So here from, we just don't have this file here. In fact, our config info is currently just a default value. So we save this default value to the local disk write. Okay. Actually, we also have some methods here, but we haven't written them yet, because we can write some methods to control it. That is, we can also configure our endpoint. Specifically, we have several ports. Which ports are exposed? Which ports are not exposed? We can add them in the form of k-value. For example, opening the login port here, enabling the registration interface, enabling the payment interface. We can do further expansion here. We didn't write it here, just to let you know. Because I can show you our code here. You see, there is actually a unique function list here. This might be done using this shorthand method. And the shorthand is mainly for our convenience too. Look, this function list, that is, it is convenient for us to know which interfaces we have enabled. This method is done using savings. We did not include it here because we don't have that many interfaces. We are now making all of them basic. So that's how it is. Now we provide a method to get our current configuration information. Then we return a getInfo. Okay. Then we need to return it. Actually, here we can just return this directly. Good. This time it's const. We don't allow it to be modified, because modifying it would only allow you to do things from the disk. Then with such a thing, we are complete. We haven't read it out here yet. Right, because writing a paragraph here is quite complex. Let's not write it for now. Let's first verify our process. As for this process, we embed it into our main loop. Let's see how it is embedded. Very similar to here. First, we need to get, so we get our current server configuration. As for this server configuration, it's here. We retrieve it using this get method. Once we have it, we yes, we are passing this reference. You can see the pointer. This side is the pointer. So once we get it, we need to initialize it. Then we start it up at this point. Okay, then we need to check this position. We should actually print out this position, because as the engine changes, it might sometimes do some bad things. You never know where these programs might fly off to. This is very normal. We definitely have this XGSampleServer. Here, it flies to this position. You see, this is some kind of data from the struct we just discussed. So now we want to, if we want to change this configuration, can we read it in? Right. We probably can't read it in yet. The reason we can't read it in It's because we haven't written this part yet. So now we are writing the part about reading the configuration. This configuration does not support being written back in code. It only allows reading from the disk. This thing, because this avoids in case someone attacks your server program and also changes your local configuration. That is not a good thing. Then here we first prepare a T-map of string in this key value form, right? Then we start to iterate through each line. Here we could use the config to write it. There is no problem using it. We haven't written these parsing by hand for you before, so we'll write it by hand. So first of all, we first determine if it is the first row, if it contains these two. If this row contains these two items, it proves that it is the first row. If it is the first row, actually, we pass this information, add it to our header. Look, the black one is called tmap. It proves that this is the header. Actually, we don't need it. We are just keeping it here because you definitely have many fields moved out, right? If it is not the first row, we prepare this left and right. Left and right. So left side is type, the right side is data. We split it according to the equal sign. After splitting, we add it to our key value flow. In this way, we have performed a simple reading of all the information. It is read into our tmap. And then at this point, this server version is hot. This is done by the engineer. This place only allows hard coding. That is, you are only allowed to change this position through hard coding. Change this place. So how do you hard code it? You just modify this. Modifying this is the correct approach. Yes, because this server version is quite special, so only hard coding is allowed. Therefore, we will not read this config info from this location. We will not read the derivation parameter from TIU into our memory, because this only allows us to hard code it in the struct. And what we need is to write this token, our token, which is read from the disk into our memory. And here we need to read this port into our memory. And note here, this is a TUI. We read it first. It's an F. Actually, we need to convert it to an int type, and this part is particularly error prone. This way of writing could easily cause you to miss a signal, or it's easy to make mistakes even when scanning. And here, this is where we take our MD5 encryption count. We also read it in. Okay, good. Then, after we finish reading, actually we still need to make a judgment. What kind of judgment? That is, if the parameter you read is inconsistent with the parameter we wrote by default. That is, we hard-coded the server version in the struct, and the service version you read from your txt are inconsistent. It proves there is a problem. Prove whether you secretly changed that text file just now, a file like this. It's this file. You yourself went and changed this on page. That is to say, this file. Changing this parameter is useless because you are not allowed to modify this parameter. Only these few parameters are allowed to be modified. As long as you change this parameter, it will be inconsistent with our compiled program. If inconsistency is detected, then we will have to perform some special operations. Okay, so what operations will we perform? Actually, it's very simple. We consider your configuration here to be unreasonable. So you change this thing. We think that your loading directly resulted in a loading failure. Then we prepare a new content here. Then we perform an overwrite in this scenario. And here we still overwrite it in this way. Then we prepare a new TLV. Then when we write your latest server version into it. And these parameters are still your original parameters. That is, pay attention here. Writing it as S and I should be fine. There shouldn't be any problem. Then we save it back, right? I mean, that's what I think about this operation. It just prevents you from secretly modifying the server. That is, some people say the versions are inconsistent. Then I do something bad. He'll say, this version. The server version is 1.2. The client is 1.3. I take the server version and directly change it to 1.2 for you. So can you do this kind of thing? You can do it, but I block it from the code side. This dangerous operation of yours, run just because you randomly changed the code. You didn't read the instructions. That is, it's blocked for you here. Of course, some judgments need to be made here, but generally, there won't be any issues. because this is all from our manufacturer. We are the server side. We are the manufacturer. Our development is very standardized and procedural. So here I am. We are just demonstrating this concept to everyone. Then right here, we can set the breakpoint at this position. Now let's execute it. To execute, we'll start it up. Okay, then after entering, you will see that the information here has already been read. Right, they are exactly the same. This must be consistent with the version of our struct. If we assume we do something bad here, we do something bad. Someone must be up to no good. Let's do something bad here. Let's change this version to 11. This thing can be written arbitrarily. But don't write the count randomly, because it will fail. Let's set it to 5. Let's set it to 80,033. Now let's read it. Let's see if it can be read in successfully. Good, okay. After we come in, you will see that we have successfully read it in. Right, this server vision doesn't seem to have been read correctly. Let's take another look. It's normal if it wasn't read correctly, because it's this place. Because of this thing, it is actually still our default. The default 1.1.0, but in this value here, you will see that it has become 11.1. These two are inconsistent. I will directly overwrite it for you, but I won't touch your other data. So this code is mainly meant to do this. Let's check again. You will find that this version, the server version, has changed back again. So this is a clever trick. Here we are, okay? So that concludes this lesson. But please note, in this place, we have this here. We go and get this thing. Then we will definitely need to recycle it, because the resources we apply for ourselves, the engine does not know about them. So how do we recycle it? When we are inside this defense, we directly get this thing of ours. We then recycle in reverse order. We recycle in reverse order. Because there is a nuance here, that is the order of your declarations, must be opposite to the order of your recycling. That is, whoever applies the resources first will be the last to release them. That's the concept. Actually, it's a bit like the concept of the execution order between the subclass constructor and the parent class constructor, that kind of concept. Okay. Then let's compile it again. There shouldn't be any problem. Okay, that's all for this lesson. Mainly, I will explain to you how to configure in an independent program, such as local parameter configuration.